Before we dive into today's mind-blowing topic, make sure to hit that like button, subscribe, and ring the notification bell so you never miss an epic science adventure. And while you're at it, drop your wildest video ideas in the comments below. So, imagine this. You're walking down the street, sipping your coffee, maybe scrolling on your phone, and suddenly, scientists announce that a miniature black hole has appeared somewhere on Earth. Not in space, not in some distant galaxy, but right here on our planet. A black hole you could theoretically see, or at least detect with sensitive instruments. Your brain immediately jumps to catastrophic images, cities getting swallowed, the planet collapsing, everything gone in an instant. But is that what would actually happen? Let's find out, because the reality is both stranger and more fascinating than fiction. First, let's talk about what a black hole really is. Most of us know black holes from movies and science fiction. They're often portrayed as cosmic vacuum cleaners, sucking up everything in their path. But in reality, a black hole is simply a point in space where gravity is so strong that nothing, not even light, can escape it. The boundary around it is called the event horizon, and anything that crosses it is effectively trapped forever. Black holes form when massive stars collapse under their own gravity, compressing huge amounts of mass into an incredibly tiny volume. Some black holes in the universe weigh millions or even billions of times more than our Sun, but a miniature black hole on Earth would be a different beast entirely. So, let's imagine our mini black hole. It's tiny, maybe just a fraction of a millimeter across. Don't let its size fool you, despite being microscopic. Even a black hole with the mass of a large mountain would have intense gravitational effects in its immediate vicinity. It wouldn't be something you could just pick up and toss in your pocket. If it appeared on Earth, the first question scientists would ask is, how stable is it? Because black holes are known to evaporate over time due to a process called Hawking radiation, named after the legendary physicist Stephen Hawking. Tiny black holes are expected to evaporate extremely quickly, releasing vast amounts of energy in the process. So, if this mini black hole popped up, it might vanish in seconds, potentially causing a catastrophic burst of energy, or it could linger for longer, slowly devouring matter around it. Let's start with the worst-case scenario. You have a mini black hole that somehow doesn't evaporate immediately. What would happen next? Well, its gravitational pull would be strongest, very close to it. If it appeared in an open field, for example, the soil, rocks, and air right around it would start accelerating toward it. At first, the effect would seem negligible because of the tiny size, but gravity is sneaky over time. It can gather more and more mass. Unlike a typical disaster, this isn't an explosion you can run away from. Instead, the black hole would quietly start consuming matter, growing as it goes. Scientists estimate that a black hole the size of a grain of sand could eventually consume the entire Earth. But it would take an incredibly long time, years, maybe even centuries, before it reached catastrophic proportions. So, for the immediate moment, humans might not even notice anything unusual. But there would still be subtle warning signs. Objects nearby would feel heavier, and any loose material could start moving toward the black hole. If it were in a lab, scientists might detect it first by measuring unusual gravitational forces. Think of it like a tiny whirlpool in the fabric of space-time. It doesn't matter how far you are from it at first. It's the cumulative effect that counts. And this is where things get really interesting because unlike other natural disasters, a black hole doesn't respect geography. There's no floodline, no fault line, no weather pattern. Its influence is universal and depends solely on its mass and proximity. Now, you might be wondering about the atmosphere. Would the black hole suck the air right out from around it? In theory, yes, but the scale matters. A tiny black hole won't suddenly vacuum up the entire atmosphere like in a sci-fi movie. Instead, air molecules closest to it might start moving in strange ways, creating a mini vortex. In laboratory conditions, this effect could be measurable, but not immediately catastrophic. As it consumes more matter and potentially grows, its sphere of influence expands. The air, rocks, and even water would slowly be pulled in, changing local conditions and potentially creating a zone around it that's completely uninhabitable. The question then arises, could we stop it? Scientists have considered many theoretical ways to neutralize a rogue black hole. One idea is to shoot it with energy or matter in a way that changes its momentum, essentially nudging it away from Earth. Another approach could be to surround it with incredibly strong magnetic or gravitational fields to contain it. But here's the problem. Black holes don't play by our rules. They aren't made of matter in a conventional sense. They are the curvature of space-time itself. You can't just tie a rope around one or lift it with a crane. Any attempt to grab it could backfire spectacularly. In practice, the most likely scenario if a black hole appeared on Earth is that scientists would monitor it carefully, calculating its exact mass, rate of evaporation, and trajectory, and hope that Hawking radiation does the job for them. Speaking of Hawking radiation, let's dig deeper. For tiny black holes, this process is intense. The smaller the black hole, the faster it radiates energy, and the faster it evaporates. A mini black hole with the mass of a few billion kilograms could emit a burst of energy equivalent to a nuclear bomb in its final moments. That's right, if a microscopic black hole appeared in your city and evaporated, it could create an explosion capable of leveling a large area. But this is likely to happen only once, and it would be highly localized. If you're far enough, you'd just see a flash of light or detect unusual radiation. The key takeaway here is that mini black holes are dangerous. But the real danger comes from the energy released when they disappear. Not from a long-term swallowing of the planet, at least in the immediate sense. Now let's get imaginative. Suppose the black hole appeared in the middle of the ocean. Water would start falling in, creating a whirlpool unlike anything we've ever seen. Currents and tides would be disrupted, potentially creating massive waves. Fish and marine life in the immediate vicinity would vanish, but the overall ocean wouldn't be swallowed instantly. The black hole's gravity diminishes rapidly with distance, so most marine life, far from the epicenter, would be safe, at least initially. Over time, if the black hole grew, the ocean's mass could accelerate its growth. But again, the timeline is much longer than cinematic portrayals suggest. There's another fun angle to consider. What if humans tried to study it? A black hole that small could be the most valuable scientific object in history. Physicists would flock to study its properties, test theories of quantum gravity, and maybe even figure out a way to safely extract energy from it. The danger here is that experimentation carries risk. Miscalculating its mass, accidentally feeding it matter, or misjudging its evaporation rate could have serious consequences. But for the first time in history, humanity might have a black hole in a controlled environment, providing data that could revolutionize physics. Imagine laboratories around the world debating whether to observe it or shield the planet from it. It would be the ultimate scientific dilemma. Let's also consider the impact on infrastructure. A black hole on Earth would interact with metal, soil, water, and even electronics in unpredictable ways. Satellites above might detect gravitational anomalies, potentially affecting GPS and communication systems. Bridges, skyscrapers, and power plants near the black hole could be at risk if its gravitational influence increases locally. Engineers would be scrambling to reinforce structures or evacuate zones. But here's an interesting thought. A black hole doesn't care about laws or borders. Its pull doesn't stop at fences, city limits, or oceans. It's impartial, indifferent, and relentless in its physics. The planet might survive for decades before catastrophic consequences, but localized effects would be intense. Another fascinating aspect is time dilation. One of the weird things about black holes is that time behaves differently near them. Clocks close to a black hole run slower relative to clocks far away. If you got too close, let's stress 2 close seconds for you, might be hours or days outside. In a mini black hole scenario, this effect would be subtle because of the small mass, but it's still real. Imagine experiments where scientists measure time discrepancies, confirming predictions of general relativity in a way never possible before. This is where science fiction and reality blur, showing us just how strange our universe can be. But let's not ignore the psychological factor. The idea of a black hole on Earth is terrifying. Even if it's small, the mere knowledge that an object capable of consuming the planet exists in our backyard would change society. People might panic, stockpile supplies, or relocate from high-risk zones. Governments and space agencies would have to communicate carefully to prevent mass hysteria. The black hole could become a global media sensation, a symbol of human vulnerability, and a reminder of how tiny we are in the cosmic scale. Now, you might be thinking, could this be turned into energy? Some theoretical physicists have speculated that controlled black holes could be used as power sources. A mini black hole could become humanity's ultimate battery if we survive long enough to learn how to handle it. Okay, so what if we take a step back and look at the long-term scenario? Assuming the black hole doesn't evaporate immediately and humans can't safely intervene, what happens over centuries? The black hole would gradually consume nearby matter, growing as it goes. Cities, forests, oceans. Eventually, even the crust and mantle of the Earth could be drawn in. But because it starts tiny, this process would be extremely slow. The Earth would likely remain intact for a very long time, with most humans and ecosystems noticing only subtle anomalies at first, strange tides, unusual gravitational measurements, or minor earthquakes localized near the black hole. Over hundreds or thousands of years, the consequences would become more dramatic, but in human lifespans, the immediate threat would be minimal if the black hole is truly microscopic. And here's a mind-bending twist. As the black hole grows and consumes Earth, its mass increases, and with it, its gravitational pull. Eventually, it could reach a tipping point where the entire planet becomes unstable. But even then, the process would be much slower than science fiction often portrays. Hollywood loves to compress cosmic events into a few minutes of screen time, but in reality, a black hole's appetite is steady, slow, and governed by the laws of physics. Humanity would have time to observe, adapt, and maybe even develop technology to escape or survive. So, what can we take away from this? A mini black hole on Earth would be dangerous, yes, but it wouldn't instantly destroy the planet. Its immediate impact would depend on its mass and evaporation rate. The long-term consequences could be severe, but they unfold on timescales far beyond a human lifetime. The real excitement comes from the science, the chance to study an object that challenges our understanding of gravity, quantum mechanics, and space-time. And while we might not be able to control a black hole, we could certainly learn from it, prepare for it, and even harness its energy in ways that today seem impossible. Before we wrap up, don't forget to hit that like button, subscribe, and ring the notification bell if you haven't already. And now I want to hear from you. If a mini black hole appeared on Earth, what would you do first? Would you run, hide, or try to study it? Drop your thoughts in the comments below, and let's have a conversation about this mind-bending scenario. Who knows, your idea could inspire the next video. Thanks for watching. Stay curious, and remember, the universe is stranger than fiction, and sometimes, just sometimes, it lands right in our backyard.